Hello, dear students. Let's start a new topic. Application of Avogadro's law. This topic from chapter 5 of class 10th in subject chemistry. Let's open your book and come on the page number 87. Now, application of Avogadro's law. There are many applications. The first application is explanation of Gay-Lussac law. So Avogadro's law explain the Gay-Lussac law. Now what is the Gay-Lussac law? According to the Gay-Lussac law, when the substance combined or produce, then always they combine and produce in a simple ratio of their volume according to the Gay-Lussac law. That means the substance combined in their simple ratio and produce in their simple ratio in any chemical reaction. Now consider the following equations. When hydrogen gas combined with the chlorine gas, then it's produce the HCl molecules, 2 HCl molecules. After balancing the equation, 2 HCl molecules. So according to the Gay-Lussac law, one volume of hydrogen combined with one volume of the chlorine gas, then it produce 2 volume of the HCl. So one volume combined with one volume, it produce the 2 volume. That is the hydrogen and chlorine combined in their simple ratio of volumes. Now according to the Avogadro's law, here in volumes, n molecules of hydrogen combined with n molecules of chlorine, they produce the 2n molecule of the HCl. If you consider the 1 molecule of hydrogens, then 1 molecule of hydrogen combined with 1 molecule of chlorine, and it's produce the 2 molecule of the HCls. So Avogadro laws say that if at constant temperature and pressure, the equal volume of gases always contains equal number of molecules. So one volume of gases contains 1 molecules, one volume of chlorine gases contains 1 molecule, and 2 volume of HCl contains 2 molecules of the HCls. 1 molecule, as you know that 1 molecule of H2, that means 2 atoms, because H2 hydrogen is a diatomic, so 2 atoms. Chlorine, 1 molecule of chlorine is also equal to the 2 atoms, because chlorine is also a diatomic. Now 2 molecules of the HCls. So 2 atom hydrogen combined with 2 atom chlorine produce the 2 molecules of HCl. If we divided this with 2, then 1 atom of hydrogen combined with 1 atom of chlorine, then it produces 1 molecule of HCl. That is, 1 molecule of HCl is formed when 1 atom of hydrogen combined with 1 atom of chlorine. So according to the Avogadro law, the Gay-Lussac law also be explained. So thus the Avogadro law explains Gay-Lussac law of combining volume. Now in the Gay-Lussac law, at the constant temperature and pressure, 1 volume of hydrogen combined with 1 volume of chlorine, and it produces 2 volume of the HCl. It means the one molecules of hydrogens combined with one molecule of chlorine, and it also produces the two molecules of the HCl. So the Gay-Lussac law can be explained by the using of Avogadro's law. Now, second application of the Avogadro law is determination of atomicity of gases. What is the atomicity? First, the number of atoms present in one molecule of an element is called its atomicity. As for example, H2. H2 is a molecule. In H2, the hydrogen has two atoms. So the atomicity of the hydrogen in H2 molecule is 2. Now, the atomicity of the gases can be determined by using the Avogadro's law. Avogadro's law says that at constant temperature and pressure, equal volume of gases always contains equal number of molecules. So, for considering the following reactions such as H2 when combined with Cl2 then produce the two HCl's. In this case, by Gay-Lussac law, one volume of hydrogen combined with one volume of the chlorine, it produces the two volume of the HCl's. And by Avogadro laws, according to the Avogadro law, if temperature and pressure is similar, then equal volume of gases contain equal number of molecules. So if consider the n molecule of the hydrogen, then n molecule of the chlorine, both combined, then produce 2n molecules of the HCl. That means one molecule of hydrogen combined with one molecule of the chlorine gas, they produce two molecule of the HCl. So one molecule combined with one molecule then produce two molecule. That means so half molecule of H2 combined with half molecule of the chlorine, then it produces the one molecule of the HCl. That is, one molecule of HCl equal to half molecule of H2 plus half molecule of Cl2 gas. One molecule of HCl means half molecule of chlorine and half molecule of H2. But as you know that half molecule of H2 is equal to one atom of oxygen, because H2 is a diatomic molecules. So H2 is a diatomic molecule. So half molecule of H2 equal to one atom of hydrogens. So one molecule of H2 equal to two atoms of hydrogens. So it's proved that, it's determined that hydrogen is a diatomic, because one molecule of hydrogen is equal to two atoms of hydrogens. Now the third applications of the Avogadro's law, determination of the molecular formula of a gaseous compound. Molecular formula of a gaseous compound can also be determined by using the Avogadro's laws. Consider the following equation. When ammonia gas produces nitrogen and hydrogens, after balancing the equations, two ammonia gas produce one nitrogens and three hydrogen gas. So by Gay-Lussac, two volume of ammonia produce one volume of nitrogen and three volume of the hydrogens. So by Avogadro's law, volume equal to the number of molecules. So the two molecules of ammonia produce one molecule of the nitrogen and three molecules 3 molecules of the hydrogens. So 2 molecule of ammonia gives 2 atom of nitrogen gas, because nitrogen is a diatomic, and 6 atoms of the hydrogen gas. Hydrogen also a diatomic, so 3 into 2, 6 atoms of hydrogens. Now if 1 molecule of ammonia, then 1 molecule of ammonia produce 1 atom of nitrogen and 3 atoms of the hydrogens. So 1 molecule of ammonia equal to 1 atom of nitrogen and plus 3 atoms of the hydrogens. Hence the molecular formula of ammonia is 1 atom of nitrogen and 3 atom of the hydrogen, so NH3 is the molecular formula. So by applying the Avogadro's law, we can determine the molecular formula of a gaseous compound. Now the third application is establishes relationship between the relative vapor density of a gas and its relative molecular mass. That is 2 into relative vapor density equal to relative molecular mass of a gas. That means the relative molecular mass of a gas is equal to 2 into relative vapor density. So this relationship established by the using Avogadro's law. Now first, relative vapor density. What is the relative vapor density? It is the ratio between the masses of equal volume of gas or vapor and hydrogen under the same pressure and temperature. That is, the relative vapor density equal to the mass of volume V of a gas and equal volume of the mass of hydrogen atom, so divided by mass of volume V of hydrogen gas. So according to the Avogadro laws, volume of a gas can be substituted by the molecule of a gas if the temperature and pressure is similar. So equal volume of a gas always contains the equal number of molecules at similar temperature and pressures. So hence relative vapor density is equal to, now here the volume substituted by the molecules, the mass of 1 molecule of a gas or vapor divided by the mass of 1 molecule of hydrogen, and 1 molecule of hydrogen is also equal to the 2 atoms, because hydrogen is a diatomic, so mass of 2 atoms of hydrogens. Now multiply by 2 on the both sides of these equations. After multiplying, we get the 2 into relative vapor density equal to mass of 1 molecule of gas vapor divided by the mass of 1 atom of the hydrogen, because the 2 is cut by the another 2, so 2 and 2 cut, and 1 is remains, so mass of 1 atom of the hydrogen gas. And as you know that the mass of 1 molecule of gas divided by the mass of 1 atom of hydrogen gas, this is called the relative molecular mass of a gas. So relative molecular mass of a gas, when related with or compared with the mass of 1 atom of hydrogen gas, that mass is called the relative molecular mass of a gas. So this value is equal to the relative molecular mass of a gas or vapor, and this remains 2 into relative vapor density. So it's proved that the relative molecular mass of a gas or vapor is equal to 2 into relative vapor density. This formula is proved. So the relation between molecular mass and vapor density is here, and this is proved by the applications of the Avogadro laws. As for example, the relative vapor density of gaseous chlorine is 35.5. So its relative molecular mass equal to 2 into relative vapor density, that is 35.5 equal to 71. Now the next application is the fifth applications of the Avogadro laws is establish the relationship between gram molecular weight and volume of the gas at STP, standard temperature and pressure. Establish the relation between gram molecular weight and volume of the gas. This is volume of the gas is also called the molar volume. Now, as you know that the weight of 1 liter of a gas equal to density of a gas. So the weight of 1 liter of a gas is equal to the density of a gas. So density of a gas is equal to weight of 1 liter of a gas at STP. Now, to determine the molar volume of hydrogens, for the determination of the molar volume of hydrogen, now considers the density of hydrogen equal to 0.09 gram per cc, and molecular weight of hydrogen H2 equal to, hydrogen molecule equal to 2.016. So the density of hydrogen equal to weight of 1 liter of a gas at STP, that means 0.09 gram of hydrogen equal to weight of 1 liter of a gas at STP. So and as you know that the molar volume is equal to gram molecular weight by weight per liter of gas at STP. So substituting this value with this, then we get molar volume equal to gram molecular weight of hydrogens, that is gram molecular weight of hydrogen equal to molecular weight of hydrogen 2.016 gram divided by the weight per gram of gas at STP, that is density of the hydrogens. So here the density of hydrogen 0.09 gram. After solving we get 22.4 liter. Thus the gram molecular mass of all gases at STP occupy a volume of 22.4 liter. So this is proved by the applications of the Avogadro's law. So this is all about 5 applications of the Avogadro's law. Okay.